Hi, and today we're going to learn about fractional indices. I'm sure you're familiar with this symbol here. Yes, it is called the square root of A. Next, this is called the cube root of A. And finally, we have the nth root of A. The three terms here on the left are actually called surds. Now, to recall, given the equation a squared equals to 4, find the value of A. How do we solve this equation here? Yes, we will square root on both sides. On the left hand side, we will get A, and on the right hand side, we will have plus minus square root of 4. And hence, we have two answers, 2 and negative 2. Suppose we have a to the power of half times a to the power of half. Using the law of indices, we have a to the power of half plus half, which is equivalent to a to the power of 1, and hence it is equals to a. Similarly, a to the power of half times a to the power of half is actually a to the power of half squared. Note that the expression on the left and the expression on the right are the same, and hence we have a equals to a to the power of half squared. Now, how do we simplify this? Similar to the previous example, we can square root on both sides. We will now ignore the plus minus sign and we will just do a positive square root. Hence, square root of a is equals to a to the power of half. Next, let's look at a to the power of 1/3. We let a to the power of 1/3 multiplied by a to the power of 1/3 multiplied by a to the power of 1/3. Using the law of indices, we know that it is equals to a to the power of 1/3 plus 1/3 plus 1/3, which is a to the power of 1, or simply a. Similarly, we can also write it as a to the power of 1/3 cubed, because we multiplied the same term 3 times. Since the left expression and the right expression are the same, we can say that a is equals to a to the power of 1/3 cubed. Now, how do we simplify this equation? Yes, we cube root both sides, and hence cube root of a is equals to a to the power of 1/3. Finally, we will look at the example of a to the power of 1/4. Using the law of indices, we know that we can add up the powers. Hence, it is equals to a to the power of 1, which is equals to a. We can also write it in this way, whereby we have a to the power of 1/4 to the power of 4. Finally, in order to simplify this, we can fourth root on both sides. And hence, the fourth root of a is equals to a to the power of 1/4. Between the surd forms and the fractional indices. Yes, we can generalize and say that the nth root of a is equals to a to the power of 1 over n. The n at the denominator of the fraction is actually the root. And this gives us the 8th law of indices. Previously, we have a to the power of half. Now, let's see what happens if we have a to the power of 3 over 2. Likewise, we let a to the power of 3 over 2 multiplied by a to the power of 3 over 2. Using the law of indices, we have a to the power of 3 over 2 plus 3 over 2, which is equals to a cubed. Since we multiply a to the power of 3 over 2 by the same term, we can write it as a to the power of 3 over 2 squared. Once again, as the left expression is the same as the right expression, we can safely say that a cubed is equal to a to the power of 3 over 2 squared. How do we simplify this? Yes, we square root on both sides again. And hence, we have The square root of a cubed is equals to a to the power of 3 over 2. Now, this may seem to be a bit confusing at the beginning, but I'll give you some more examples and you can see what is the relationship between the surd form and the fractional indices. We will take a look at an example of a to the power of 5 over 3. Now, when we multiply a to the power of 5 over 3 this way, we will get this using the law of indices. Have you figured out what is the simplified form? Yes, it is simply a to the power of 5. Likewise, we can write it as a to the power of 5 over 3 cubed. To equate the left hand side and the right hand side, we will get a to the power of 5 is equals to a to the power of 5 over 3 cubed. Finally, having a cube root on both sides. And hence, the cube root of a to the power of 5 is equals to a to the power of 5 over 3. Now, we will take a look at one last example using a to the power of 9 over 4. Employing the law of indices, we will get a to the power of 9. Now, since we multiply a to the power of 9 over 4 4 times, we can write it as a to the power of 9 over 4 to the power of 4. At this time, you have already figured out, yes, the left hand side will be equals to the right hand side. And we can root 4 on both sides, which will result in the fourth root of a to the power of 9 equals to a to the power of 9 over 4. We shall now look at all this in the table form, and can you see any pattern between the surd form here and the fractional indices? Can you tell that the numerators here are actually the power and the denominators here are actually the roots? We can write it in the general form. The nth root of a to the power of m is equals to a to the power of m over n. And to highlight again, the numerator m is actually the power, the denominator n is actually the roots. And this concludes the ninth law of indices. To let you have a better understanding between the fractional indices and the surd form, I will make examples. We have 2 to the power of 6 over 5 here, which is the fractional index. The 6 is the power and the denominator 5 is actually the root. To convert it to a surd form, do you know which is the base? Is it 2, 6 or 5? Yes, 2 is the base. And which value should this be? This is the power and hence it should be 6. And finally, this is the root and hence it will be 5. Next, I will give you an example with a variable x. We have x to the power of 2 over 9. Again, the 2 is the power and the 9 is the root. Do you know what goes into each boxes? This will be our x, which is the base. And this is 2, which is our power. And finally, this is 9, which is our root. We will now look at one more example of 37 to the power of 9 over 2. Which number should be in this box? Yes, it should be 37. And which number should be in this box? Is it 9 or 2? Yes, it is 9. Finally, which number should be here? Do you say 2? For square root, we will actually just leave this part of the surd empty. Now, this law of indices actually states that a to the power of m over n is actually the nth root of a to the power of m. We can also write the nth root of a to the power of m in this way. Now, what does this mean? This means that you can root a first, or you can have a to the power of m first. We shall now look at some example. For example, 27 to the power of 2 over 3. Do we square it first or do we cube root it? Writing in surd form, it is actually the cube root of 27 squared. You notice that it doesn't really matter whether you square it or you cube root it first, you will get the same answer. But in this case, it is actually easier to cube root it. By having the cube root of 27, we will get a smaller number, which is 3. And hence we have 3 squared, which is equivalent to 9. Now, what happens if we have squared it first instead? To square 27, we actually get quite a big number, which is 729. And we will get 9. Can you remember what we have learned so far? We have learned the first 3 laws of indices with the same basis. Then we learn the next 2 laws of indices with the same powers. And then the zero law of indices, the negative law of indices, and for today we learn how to convert from surd form to fractional indices or from the fractional indices to the surd form. Now remember that the numerator here is actually the power and the denominator here is actually the roots. And because a here has the power 1 and roots n, and hence we have 1 for the numerator and n for the denominator. Next, we learn about the fractional indices with the power m and the roots n. As an extension, what happens if we have this type of fractional indices? Now, this is nothing new. We are just combining the negative power with the fractional index. The m here is still the power. The n here is the roots. Can you remember what the negative power means? Very good. It actually means the inverse or the reciprocal. And hence, the final surd form will look like this. Now let's look at some numerical examples. 5 to the power of negative 3 over 7. The negative is actually the inverse. The 3 is the power and the 7 is the root. We shall now convert the negative power to 1 over. Can you recall what goes into each boxes here? Yes, this is the 5, this is the 3, and this is the 7. This is actually the same as the previous law of indices. It's just that we have added an inverse due to the negative power. Do you know how to rewrite this in surd form? Very good. We have 1 over the fifth root of x to the power of 4. We shall now look at one last example. Due to the negative power, we have 1 over. Do you know what goes into this box? Yes, it is the base 12. And what goes into here? It is the power 9. And finally, what number is behind this box here? Very good. There is actually no need to write any number here because a square root does not require us to write the number 2. At this point, I will not add this as a new law of indices because it is just a combination of the previous law of indices. Please memorize all these law of indices by heart. You can pause the video at any time and it will be a good practice to take down notes. That's all for this lesson. I'll see you the next time.